Hello, everybody. Welcome back. Today we're moving on to a new topic. It's called trigonometric identities, and we're doing notes number 42. So a lot of what I explained today, you're not going to be writing down, and when there's something that you need to take notes on, I'm going to put it in a nice yellow box, and so that will be your cue to write it down. All right, so this next unit, typically we discuss 24 different things that we call trigonometric identities. There are more than 24 out there, but we just go over only 24 of them. However, this year is different, as we all know, and so we're only going to go over the top 8. And today you're going to learn what those top 8 trig identities are. So let's stop and have a moment of silence for the 16 identities we're not learning. Okay, thank you. Now, what is an identity? So let me just give you a very, very basic example so that you'll know what we mean when we say identity. This one is not even trigonometry, it's just a very basic example. Let's say I have this equation, 2x equals 10/5 x. What do you think of that? Do you think it's true? Do you think no matter what we plug in for x, it's true? I would agree with you. So an identity is a statement that is true for all acceptable x values. How do we spell acceptable? Acceptable, is that right? Acceptable, that's a big P. True for all acceptable x values. Now that will depend on the situation of what would be considered acceptable. In other words, like whatever is in the domain of that particular kind of function that we're discussing. Okay, what can you do with identities? Well, different kinds of things. One thing you could do is rearrange it if you had a need to for some reason. You can take that equation, which is true for all acceptable x values. You could suppose maybe subtract 10/5 x from both sides, and it looks different than it originally looked, but it's still true. Maybe there's a use for that in some way. Another thing you can do with an identity is use it for substitution, and you're going to see this a lot in what we do. So maybe I have the equation 2x plus 17y equals 99z. Well, knowing that 2x is equal to 10/5 x, I could substitute 10/5 x in there for 2x if I had a reason to, and this equation would be true. Okay, so basically what I'm trying to do is just give you an idea of what identity means in math and how we might be using it. Now, another note I want to make is that there's nothing necessarily special about x. So it would be the same identity if I said 2n equals 10/5 n, or if I said 2 theta equals 10/5 theta. It makes no difference. It's the same identity, just using a different letter. Okay, here we go. Now we're going to learn about trigonometric identities, 8 of them. These are the 8 that when I teach calculus, I expect my students to memorize or to remember from pre-calc. They're all great, all 24 are great, but these are the 8 that you would use the most often moving forward into calculus. Okay, I'm going to split them into 3 categories, and the first category is called reciprocal. Reciprocal identities. I'm going to leave room over there to write them, and this is something that you're going to end up writing down. So it's in a nice yellow box. Now, remember when we learned what secant and cosecant and cotangent meant, we learned the definitions of those. We learned that secant of theta is the reciprocal of cosine theta, so it's 1 divided by cosine theta. Maybe we didn't use the word identity at the time, but this is a trigonometric identity. So you already know one. Here's another one. Cosecant of theta equals 1 over sine theta. What's the third one? Say it out loud. I want to hear you say it. Very good. Cotangent of theta equals 1 over tangent theta. So we're learning 8 trigonometric identities today. You already know 3 of them. Now remember, one of the things you might get to do with these is use it for a substitution, use it to rearrange in some way. So here are some of the rearrangements you might encounter someday. Maybe you see something like this. Secant theta times cosine theta equals 1. You see how if we take that first equation and multiply both sides by cosine theta, we have secant theta cosine theta equals 1. Now, if you needed to do a substitution and you had a problem that had this product in it, you could substitute 1 for it. We'll be practicing that a little bit next time. Another rearrangement would be you could take this equation I just wrote and you could divide both sides by secant theta, and you would have cosine theta equals 1 divided by secant theta. That's also equivalent, it's just rearranged a bit. And each of these can be rearranged in those same ways. Okay, let's move on to the second category, and it is called ratio identities. There are 2 of them. So we're going to write these down once we get there. All right, remember your XYR triangle, your right triangle with angle theta, and across from theta is y on the opposite. Next to theta is x on the adjacent, and r is on the hypotenuse. Well, remember from that, we said that cosine of theta is x over r, and sine of theta is y over r. Let's do this. Let's find the ratio of sine theta divided by cosine theta. That would be the ratio of y over r divided by x over r. We have a fraction divided by a fraction, so let's change that to the top fraction multiplied by the reciprocal of the bottom fraction. And look what happens. You can cancel the r's, and you're left with y over x. But what is y over x? Looking back at the triangle, y is the opposite, x is the adjacent, opposite over adjacent is tangent. So what we have here is sine theta over cosine theta equals tangent theta. That is our first ratio identity. Tangent theta equals sine theta over cosine theta. Did you know that technically we have been using that identity for a while? Because when we have done our quadrantal angles and we used points like 0, 1, and we said that x was the cosine and y was the sine, but we wanted to know the tangent was y over x, so the tangent was sine over cosine. So we've already been doing that. There's one more ratio identity, and it is what you get if you take the reciprocal of tangent. What's the reciprocal of tangent? Cotangent. So cotangent theta equals, what's the reciprocal of this thing? Well, you would flip it upside down and you would get the cosine on the top and you would get the sine on the bottom. So that's the second ratio identity. Cotangent theta equals cosine theta over sine theta. Okay, so how many identities do we have so far? 5. How many more? 3. So let's move on to the third category for today, and this is known as the set of Pythagorean identities. Identities. Trying to get it spelled correctly. Okay, this is going in a nice yellow box. You're going to write that down. So this is also based on the XYR triangle. Get that in place again. Angle theta. And again, we know that cosine theta is x over r. So if I isolate x there, I get x equals r cosine theta. And similarly, sine of theta equals y over r. If I isolate y, I have y equals r sine theta. Okay. Now, these are called the Pythagorean identities for a reason. We have a right triangle, and so we could use the Pythagorean theorem and say that x squared plus y squared equals r squared. Now we have an expression we can substitute in for x and an expression we can substitute in for y. So we have, instead of x, we have r cosine theta, and that is going to be squared. And instead of y, we have r sine of theta, and that is going to be squared, and that equals r squared. When you square a product, like r cosine theta, you square each factor. So you square the r, and you square the cosine theta. But the way we write cosine of theta quantity squared is we put the squared before the theta. It looks like that. It means find the cosine of theta and then square it. That's what that means. And then for the other term, we have r squared sine squared theta. And on the other side of the equation, we have r squared. Look what we can do with this equation. We can divide every term by r squared. And what we have left is cosine squared theta plus sine squared theta equals 1. Now here's what I want you to do. Grab your calculator and pick any number you want for theta. You could pick 10, you could pick 20, you could pick 99, you could pick negative 142. It could be radians, it could be degrees. Anything goes. I want you to try this. Maybe even try it for multiple numbers. So take your number. Let's say I try theta equals 71. So I take cosine of 71. Now in my calculator, I need to put parentheses around that whole thing and then square it. And then sine of 71, parentheses around the whole thing and then square it. Add those together, see if you get 1. If you type it in correctly, I bet you're going to get 1. And just know that all of your classmates are picking a different number than you most likely, and everybody is getting the same thing, showing that this is truly an identity. So let's write it down. Cosine squared theta plus sine squared theta equals 1. You can rearrange it. You can say sine squared theta plus cosine squared theta equals 1. You can rearrange it like cosine squared theta equals 1 minus sine squared theta. That kind of thing is done a lot. Sine squared theta equals 1 minus cosine squared theta. There's all kinds of ways it could be rearranged. Here's what you cannot do. This is very tempting. People think it would make sense to square root this thing. But let me show you something. Let's say you had this equation. 1 plus 2 equals 3. Okay, first of all, are we in agreement about that? Good. Now, what if it was square rooted, square rooted, square rooted? Is it still true? It is not. So, you cannot just square root the terms individually in an equation. And so I'm trying to say that it is not true that cosine theta plus sine theta equals 1. That won't work. You can't just square root, square root, square root. So, leave it like this. It has squareds in it. You can rearrange it, but not square root it. Okay, there are 2 more Pythagorean identities, and let me show you where they come from. So what we do is we start with that one, cosine squared theta plus sine squared theta equals 1. And we divide both sides of the equation by cosine squared theta. Now if you divide a sum by something, then you're dividing each individual term by that. So divide each term by cosine squared theta. And let's see what we get. Cosine squared theta divided by cosine squared theta is 1 plus. Now, sine squared theta divided by cosine squared theta is sine theta divided by cosine theta squared. And what did we just learn sine theta divided by cosine theta is? Yes, tangent theta. So that is 1 minus tangent squared theta. And then on the other side, we know that 1 divided by cosine is what? Secant. So this is secant squared theta. 1 plus tangent squared theta equals secant squared theta is the second Pythagorean identity, and it can be rearranged. You can have the tangent squared theta first and the 1 second. So let's write that here. 1 plus tangent squared theta equals secant squared theta. And now one more. We start back with the original Pythagorean identity. And instead of dividing both sides by cosine squared theta, can you guess what we're going to divide both sides by? That's right, sine squared theta. And what is cosine squared theta divided by sine squared theta? Well, what is cosine divided by sine? That's cotangent. So this would be cotangent squared theta. And what's sine squared theta divided by sine squared theta? 1. And what's 1 divided by sine squared theta? Well, 1 divided by sine is cosecant, so this would be cosecant squared theta. And that is the next, third, last Pythagorean identity. How did I have it? Cotangent squared theta plus 1. We can write the 1 first if we want to, just so they look alike. 1 plus cotangent squared theta equals cosecant squared theta. Okay. Notice that if I went back to the ratio identities, in the most recent part of the lesson, we could square both sides of these. See, cotangent squared theta is equal to cosine squared theta over sine squared theta, because you're just squaring the whole side of an equation and squaring the other whole side of the equation. That's fine. You could cube both sides. You could raise both sides to the 4th. You could do all kinds of things like that. Okay, where do we go from here? Well, we are going to do some practice problems in our next lesson. So for now, this is what I want you to do for your homework. I want you to make flashcards of these 8 identities and memorize them. So probably a few minutes each day of practicing with your flashcards to memorize these 8 identities. You are so lucky. You don't have to memorize 24 identities, or maybe you're unlucky. I guess time will tell. And then what I want you to do is send me pictures of your flashcards, or send me a picture. I don't need a picture of every single, like I don't need 8 pictures, but send me a picture of your flashcards. That will be your homework assignment. Hey, if you want to send me a picture of something else, like send me a picture of what you made for dinner, or your garden that you're growing, or your cat or your dog, or you having fun, or your Monopoly game that you're playing with your little brother. I don't know. Give me some entertainment. It's pretty quiet around here. Okay, thanks everybody. See you next time.